Okay, well, let's begin. We could have the next slide, please. Our topic today is IHE North America Connectathon. We're going to be taming the imaging AI world. So a very interesting topic, and we have a great panel to present. First of all, my name is Mike Nussbaum. I'm on the IHE International Board, have been for a very long time, and I'm pleased to be your Master of Ceremonies today. Just a couple of housekeeping items. This webinar is being recorded, and the recording will be posted online on the IHE International YouTube channel. You can find that by going to YouTube and then just searching for IHE International, and it'll all come up. The slides will also be available as part of the YouTube broadcast of this. If you go to the comments section after the YouTube, you'll see a link to where the slides will be posted. So all this information will be available to you after the webinar. During this webinar, we will invite your written input and through the chat function. The chat function, of course, is part of the Teams environment that you're in. And if you could put your questions as we go into the chat, we'll try and get to as many as we can as time permits at the end of the webinar. If we can't get to your questions, someone will make sure that they connect with you directly to ensure your questions are all answered. So please be forthcoming with your questions. Next slide, please. So we're here to talk about the IHE North America Connectathon week and how imaging is going to fall within that context. I'm assuming that you've all seen the material that's been presented on this year's IHE North America Connectathon week, which is going to be happening for the very first time in Canada. I happen to be from Canada, and I'm very, very proud to be one of the Canadians on this call. There are several on this call, to be hosting on behalf of IHE North America. IHE North America is actually made up of IHE Canada and IHE USA. The Connectathon week is full of lots of things going on. First and foremost, the North America Connectathon. This little diagram here has some explanation about what goes on for those of you who haven't been to a Connectathon before. I'm sure you have a chance to examine what a Connectathon is. And it's something that doesn't happen anywhere else in the industry, where vendors can test with interoperability with other vendors, people who they compete with day to day, but in terms of interoperability, collaboration is required. And this happens at the Connectathon. Connectathons have been going on for 25 years now. So IHE has got lots of excellent experience and tooling to facilitate a Connectathon. But there are three other events going on during that week. There is a projectathon for Canada. There's a small error in this. It's going on from the 5th to the 7th of February. Also in Toronto, also in the same facility. And that is testing interoperability in a Canadian context. You'll hear more about that, and there's lots more about that on the website. We will again be having the IHE North America Experience Days. That is multiple days, February 3rd and 4th, the first 2 days of the week. That is a conference. If you haven't been to a Connectathon week in some time, then you'll be pleased to see that we actually host a very extensive conference in conjunction with the Connectathon week. And it's done in parallel with the Connectathon activities on the floor. There's also something new that we're doing that has been tried in about 3 locations, started in, actually in 2 locations now. It started in Europe, and it's migrated now to IHE North America for the very first time. We're doing a plugathon. And a plugathon is something that is preliminary to a Connectathon. That is, it attracts people that have, that may not be ready, or their systems may not be robust enough to go to a Connectathon, but it gives them an opportunity to do a little hacking, to do a little talking, to do a little discussing, and to learn. And the plugathon has some very interesting tracks, and you'll hear more about the plugathon later in this presentation. The next slide, please. The 4 components of this are mapped against who might be coming to attend one of these events or all of these events. Of course, the vendors typically would be going to everything. There's lots of different other participants. We have government people, we have providers, we have subject matter experts, clinicians, consultants, etc. There's something for everybody during this week. And I just want to just close by saying that this is put together. This is an extensive endeavor. We're expecting many hundreds of people. And to visit Toronto, it's going to be great. And it's going to be one of the signature events in North America for this year for all the events that go on in digital health. It's been hosted by Canada Health Infoway with tremendous sponsorship as well. On behalf of IHE USA and IHE Canada, it's being fully facilitated by IHE Catalyst. And we have other participants, including IHE International, HIMSS, and RSNA that are also taking part in bringing this to you. So with that, let's begin. I'd like to, first of all, go to the next slide, if you wouldn't mind. I'd like to introduce our panelists. And so we will have, the agenda is put up here. We're going to have an introduction. I've done the introduction, excuse me, an overview by David Kwan, and then a number of presentations around the IHE profiles related to AI in imaging. And that's going to be done by three distinguished individuals. So first of all, David Kwan. David, you may probably, he's an informaticist. He's been around radiology for a long time. He's serving as the current IHE Canada chair and representing Canada on the IHE International Board. David is quite a subject matter expert in the domain of diagnostic imaging, passionate interest in structured and synoptic radiology reporting, and standards terminology. David has been an active member of IHE Radiology planning and technical committees. Over the last 3 years, he participated in the development and publication of the IHE IMR and IHE reporting applications technical profiles, and recently developed and soon to be published the IHE Imaging Diagnostic Report Profile. David will be joined by Kevin O'Donnell. Anybody who's been involved in IHE for the last 25 years will know Kevin. He is another Canadian but lives in the US. He is a senior R&D manager at Canon Medical Research USA. His focus is on standards and interoperability in medical imaging. He's a graduate from the University of Waterloo in Canada with a bachelor's degree in system design engineering, and from the University of British Columbia, near where I live, a master's degree in electrical engineering. As an enthusiastic believer in the value of standards to healthcare in general and medical imaging in particular, Kevin is a past chair and longtime contributor to both the DICOM standard and IHE Radiology, and is a current member of the SIM Board of Directors. And joining David and Kevin is Kinson Ho. Kinson is a staff engineer at Tempus. His focus is on connecting multimodal data to support intelligent precision medicine. He has over 20 years of experience in healthcare informatics as a developer and architect, ranging from PACS and VNA implementation, regional health exchange projects to cloud-native enterprise imaging. And previously, Kinson served as IHE Radiology, served in IHE Radiology as chair of the co-chair of the planning and technical committees, and is the author of several of IHE's profiles. So with that, I'd like to turn the floor over to David Kwan. David?
And you're on mute, David.
Thanks, Kevin. I think I get used to these platforms, but they're all different. If you can bear with me, I'm going to give a very brief landscape overview of imaging AI before I turn over the heavy lifting to both Kevin and Kinson. So, integrating imaging AI, the global market for AI-enabled imaging solutions was valued approximately at $1.35 billion in 2021. It is projected to grow to $18.4 billion by 2032. There's a lot of investment going on and a lot of money being spent in the segment of technology. The FDA, as of August 2024, authorized 950 AI machine learning enabled medical devices. Over 100 of these occurred in 2024 alone. So it is climbing exponentially. Just to give you an idea of what AI can do, AI models have shown high accuracy in predicting demographic factors from medical images. For example, an AI can predict a patient's age just from a chest X-ray with 75% accuracy. Clinical applications, AI extensively used in radiology today for such tasks as detecting abnormalities in CT, MR, and X-rays. FDA has approved more than 200 of these commercially AI available products. But as we climb on adoption of this new technology, we are facing some major areas of challenge and barriers. Number one, workflow integration. It is being touted as plug and play. We're learning that is slightly a misnomer. AI tools need to be integrated smoothly into existing workflows, or we're gonna stumble where we stumbled in the past, where we made our radiologists and users become data entry clerks. So we need to integrate smoothly into PACS and dictation systems. This requires standardization and can be complex due to the very systems and workflow. The other is data variability and generalization. And thirdly, clinical utility. We have to demonstrate, or the products that are being sold have to demonstrate clinical utility in terms of speed, accuracy, and efficiency. You know, what will the tool reduce time in which to find a critical finding and then report it and act upon it? Does the tool make the radiologist more diagnostically accurate? And does the tool reduce the radiologist's time spent reviewing and reporting the studies? These are all issues that what Kinson and Kevin will talk about on how to tackle this. So what is to come? Two are listed on the slide, predictive analytics and personalized medicine, but I'd like to also draw out the trend that is coming is greater access to electronic health records and such initiatives as IPS, as well as multi-country access to patient records and images. And I have to remind everyone that includes the patient. And this is an area that us in radiology have tended forgotten, that we tend to focus in on the user, which is a radiologist alone. And we have to remember there's a new stakeholder on the horizon, which is the patient. And the second trend is, you'll see this more and more, because the last 3 cycles have aimed at image reporting. And that is the trend that generative AI is going to disrupt image reporting process. And with that, hopefully I've outlined the landscape, and I'll turn it over to Kevin.
Great. Thanks, David. And thanks, Mike, for the kind introduction. We were going to try and do a screen share shift. So let's see if this works. Is this projecting okay?
Looks good, Kevin.
Excellent. Okay, so the first up, we're going to be talking about 3 profiles and a little bit of a fourth today. The first one up is AI results. And in this case, we're specifically talking about image analytic results in the process of doing image interpretation, for example, in radiology. And I'm sure the scenario sounds really familiar. Somebody has a really cool new algorithm that will allow you to detect pneumothorax in an image. And so they work with their hospital partner and find a way to get this detection result presented to the radiologist in the radiologist reporting environment. And everything's lovely. Well, they do have a couple other, there's another group in a different branch of the hospital that has a different reporting environment. So they've got that. Well, and then there's a few other hospitals they want to deploy this to as well. So they need to do the presentation integrations with each of those display environments. And then they've got this other one, which will do diabetic retinopathy, and one for skin lesions and wrist fractures, and you get the picture. Before long, you have many, many image analytic models that now need to connect to all these many, many display environments, and trying to tell the radiologist, well, you need to use 27 different displays to look at all these 27 different results, or that, for each vendor, every time someone new comes on the scene, you have to do yet another round of integrations, isn't tractable for anybody. It's a classic many-to-many problem, which is what standards were, built for it. This is exactly why we have standards. So IHE Radiology decided to tackle what we call the AI results profile. Our target is the AI analysis software on one end that are creating AI results, image analysis results, the PACS that is storing them, and then the image displays that are presenting them. And what we're trying to do is to standardize that storage and display of the AI results for the image interpretation process. The approach that we took is to consider a set of what we called result primitives, which we'll talk about a little more on the next slide. And then for each of these primitives, what are the encoding requirements? So how do you put these into DICOM-based storage? And then what are the baseline display requirements for each primitive? So how is the creator going to play ball? And then how are the displays going to take that standardized output and present them in a uniform way? So as kind of implied, we've got a set of actors within IHE. If you're on this call, you're probably familiar with the concept of actors. There'll be an evidence creator actor, which is the one getting the images and generating these cool AI results. But ultimately, it's the transaction where they store those evidence documents to the image manager. That's where we get into this profile. And then similarly, on the image display, when you're during the process of reviewing a study, it needs to be able to query, retrieve, and present these various image results. Now, there is other uses for this that we will focus mostly on the display side, but there's no reason why a non-display oriented image document consumer can't also play in this profile. If you're populating the imaging report, which Kinson will get into a little bit later in this session, if you're databasing all of the analytic results, if you're trying to drive clinical decision support software, those all can take advantage of this profile as well. So by primitives, we started off with one primitive would be a qualitative finding. These are things like determining that the breast composition is extremely dense and the patient needs to be notified per various mammography regulations, that pneumothorax is present. There are quantitative findings, which usually called measurements. The length of the adrenal gland nodule is 52 millimeters. There are locations that come out of a lot of these, that finding a feature and localizing it within an image or within an image stack. There are segmentations where we've determined the surface of a nodule, which then from which you can derive other things like volume measurements and the like. Parametric maps, which is perhaps a little bit of an odd word, but mostly we see this being used for things like saliency maps, that if you're doing say a pneumonia detection or a pneumothorax detection, that the algorithm may produce a saliency map to kind of give a sense of which part of the image triggered its determination. Tracking IDs for being able to track tumors, specific tumors over time. So within a given patient, this particular tumor, we want to be able to correlate that this is the same tumor as that other tumor from 6 months ago. It's larger now, it's a different shape, but being able to track those longitudinally, and things like image references, that this image is the best view of the brain hemorrhage, for example. So these are the primitives, and the idea is that most AI results can be expressed in either one or a combination of these primitives. So some AI models may be more sophisticated and produce a variety of information. Some may only produce one information, but you put out then one or more objects that correlate to these. This list was based on looking through the working catalog we had from DICOM Working Group 23, which is the AI working group, as well as taking a look at a lot of the good work that ACR has been doing on their use cases within their Data Sciences Institute. So the encoding requirements for each of these, the first few fit pretty directly into DICOM SR objects, using template 1500, which is our standard point and image. You can do contours if you need to. You can do locations if you need to. And you can do ROI. So ROI contours, measurements, statements of qualitative findings. For segmentations, we did allow the second approach, in addition to the ROI contours, which is most commonly done if you're doing the ROIs in connection with a bunch of related measurements and qualitative findings. If you're doing standalone segmentations without a collection of measurements, it's more common to use the DICOM segmentation object. Parametric maps, we have a parametric map object. Tracking IDs are simply a feature of the DICOM SR that you can embed a tracking ID and UID element in related findings in the SR. And similarly, image references fit straight into the SR as well. So as you can see, lots of SR. So on the presentation side, then the AI result display behaviors, the question we were trying to answer is how does a display become AI ready without having to customize for each AI model? And in case anybody asks, the first thing that we took off the table is we're not doing screenshots. That screen captures, also referred to as secondary captures, it is a way to get it presented, but you've lost all of the semantics. You've taken all of those cool measurements and measurement values and what algorithm did this and all of the metadata and all the computer processability, and you've thrown that all away, which is specifically what we do not want to do. That the downstream machine consumers of this data are just as important as the downstream human consumers. And frankly, the humans can look at a screenshot and get the rough idea, but then they want their tooling to do something smart with it, like copy this measurement into my report. And if all you've got is a screenshot, you know, the application saying, what measurement? I see a bunch of pixels. You want me to do screen scraping and OCR or something? And so we totally bypass the screenshot. That you can certainly do that, but that's sort of the very poor man's approach to this. Baseline display capabilities are that for each of the measurements, the display has to be able to take an SR measurement, display it in the context of the image where it was measured, as determined by the image references embedded right in the SR data tree. They need to be able to display and label locations and CAD marks and context. So if it's a location primitive, you have to be able to pull up the corresponding image and put an icon. We don't over-prescribe what shapes or colors or styles of icons. There's going to be a lot of room for creativity on the display side in terms of how you filter all of these things. You're not going to want to display everything all at once, as we'll get to in a moment. But you do have to be able to display each of these. So at the Connectathon, that's what the proctors will be asking. Push whatever buttons you need to push in order to get this presentation to come up on the screen. How you do that, that's part of your product design. You need to be able to overlay and fuse parametric maps onto the associated source image, associate multiple results in a set if they're related by the tracking ID, et cetera, et cetera. There's a few more things in the same vein. So the profile has this all written out. To get a hand on the profile, if any of you haven't seen it yet, you go to profiles.ihe.net, click on radiology. You can scroll past the current technical framework, which is where all the final tech stuff is, to the trial implementation section. In this case, you'll look for AI results. All the other three profiles that Kinson and I are going to talk about, same place. And some of them have a how to read this document, which may help you navigate around them a little more. Now, the other thing I wanted to touch on with AIR is we did it in two passes. So the first pass is what we just described. But one of the things that we foresee, and actually it's kind of coming true already, is imagine each chest CT running AI assessments for abdominal aortic aneurysms, rib fractures, lung nodules. I won't read the list. You can read the list. There's the concept of opportunistic screening, that you might as well run all of these. And fine, if they come normal, you don't need to, disrupt the radiologist from their read. But if there's something of interest there, you may want to highlight it. So there's the potential for a lot of results coming out from one scan. So, dear radiologist, here's your 138 data elements. Where do you want to start? This is supposed to be making life easier for the radiologist, not harder for the radiologist. And so just throwing a plate full of primitives on their screen isn't helpful. So we introduced the result tree option, which is an extension for the AIR profile, where the result tree is a hierarchical navigation object. It's a very simple SR object with linked nodes. Here's a parent, points to its children. For each of those children, they point to a finding and then point to their children. And so each node references an individual primitive. You can start at a summary node, and maybe that's the only thing your display presents to the user is, in this case, there was a lung RADS assessment. The lung RADS came up with lung RADS 3 for the patient. Now, they can drill down then as needed. If, you can group them in different ways, but the display presents the node. And if they say, well, show me more about this lung RADS 3, it says, well, 3 nodules were identified. One was classified, 2 of them were classified as lung RADS 3, one was classified as lung RADS 2. Okay, tell me about the nodule number 1. You can then pull up, here's the location, here's the volume, here's the solidity. These are the details that contributed to rating it as lung RADS 3. For the volume, okay, show me more. Well, here's the contours of it. Oh, I see why the volume looks unusually high. It's made a mistake on the contour. So the idea with the navigation object is to let the creation system describe what it's created, and then let subsequent systems, put together useful groupings. You could make an object like this to group by main findings, or you could group by anatomy, or you could group by, here's the tree for all the abnormals, here's the tree for all the normals, given that the normals are likely to be ignored by the radiologist, relatively nothing to see there. So something else to look for within the data set. The last thing on this about capturing all of these SR objects is when people are training AI models, they often think about, well, I've got my training annotations and I'm going to generate my results annotations, but there's really a larger ecosystem there, and that those training annotations, often those came from past manual annotations. And in fact, you might group in more and more past manual annotations with additional add-ons to your training set as you are able to get more data from more institutions. You'll be storing out corrected annotations that the radiologist sees the results you provide, said that's not quite right, it needs to look like this. There are new cases that come along, that there are new types of nodules or new, new types of pathology that you're going to tackle. So the important thing is that, and of course, all of these then cross-relate to the underlying images on which those annotations were done. So this is the main reason for addressing training, testing, operations, surveillance, retraining. It all needs to be managed, which is essentially what DICOM does. It keeps all the relevant metadata, which is the main reason why we're looking at SR for capturing all of this. I'm very quickly going to touch on AIW-I. In a simplified architectural context, you've got a clinical operations layer where you're handling, this patient has this imaging study and it's about to get read by this physician, and we want to link in various AI inference engines. Now, the inference engine says, patient, I have no idea what a patient is. Imaging study, I don't know what that is. Give me a matrix of dots, a matrix of pixels, and I'll say yes or no. And frankly, the AI model itself doesn't even really know what the yes or no is. It's the layer that called it that knows that's a pneumothorax detection. And so you're going to have this incorporating each of these models into your clinical operations in some fashion. And so that was part of what we were targeting with the AI workflow profile. The idea is a generalized work list manager, so that as a study is performed, and this hospital's policy is to run lung nodule detections and coronary calcium detections and whatever on each study that is a lung screening study, for example. So the requester will basically create what we call a UPS. That's the DICOM structure for one of these work list items that says, here's the study, here's the patient. I want a lung nodule detection run on this. And here's where I'd like you to put your output. We also envisage that there'll be watchers, which may be dashboards, performance monitoring systems, or more importantly, the reporting work list system that says, well, I'm interested in what AIs are getting run on study number 4 because I'm ready to put it on the work list, but I don't want to do that until the various AI results are ready. So there's a pub/sub type model for subscribing to notifications. The requester would generally, in this case, we show a global subscription for the watcher. A requester would probably only subscribe to the things that they created. so that when a performer says, hey, I'm ready to do my next pulmonary nodule detection, is there a piece of work for that? It comes back, yep, there's 3 of them stacked up. Here's study number 4. It retrieves the content, sets it in progress. When it's finished, updates the results. The requester and the watcher get notifications if they're interested on those changes. Ultimately, it stores out the results, lists the objects that it created and where it put them in the UPS, and sets the state to complete, which allows the watcher and the requester, if they need to go and get those contents and, for example, then retrieve those and put them up for the radiologist if you're the reporting workstation. Just to highlight that previous layer, the performer here is clinically aware. It understands studies and nodule detections and those sorts of things. So in many cases, we expect that the performer is simply a front end. It won't be the actual neural network model that you'll see that neural network either embedded in it or located behind it. It can go in, strip out just the pixels that are needed, hand the pixels out. When it gets a 1 back, it puts in the correct SNOMED code for pneumothorax detected into the object and passes that out. So that's the broad kind of workflow and pattern we were envisaging with AIW-I. At this point, I think we will transfer over to Kinson, who has a couple cool things to show you about what we've been doing to automate the reporting process and multimedia reports.
Thank you, Kevin. So let me share my screen. Okay. Can you see my screen?
Yep, looks like it's coming up.
Okay, all right, perfect. Thank you. So with all the great things, with all the AI tools and all the standard that Kevin just mentioned, at the end of the day, as a radiologist, we want to incorporate all those like great results in our reports so that we can distribute to our referring physicians and help our patients care at the end. So think of what happens today. Quite often, without all the integrations that is available, many times the radiologist has to copy and paste the results from their packs into the report, or they may have to verbally dictate the results, like which nodules, which slide, which images, and what the size of the findings, things like that. Occasionally, your IT team may have very sophisticated integration to bring all those systems together, whether it's an API integration, database integration, file drops. There are many different kinds of proprietary integration. And it may work sometimes. And sometimes it may just have random errors, just annoy you, and it just makes you frustrated, like how can the system not working today? So if you think of what a general reporting workflow looks like today, we have some major systems. We have an image display system, basically that is your PACS. We have a reporting authoring tool, which is mostly your reporting system. And then we have a report repository, your EHR, and sometimes the PACS also get a copy of the result. The PACS may also have additional system integrated, like evidence creator, for example, many of the AI applications that Kevin talked about, or worklist client. There may be specialized worklist applications to drive and optimize your workflow. That's great. You have all this system in place, and how they all integrated today, kind of like Band-Aid. It can be API, it can be file drop, it can be database integration, there may be other proprietary integration method. It's all kind of work together, but very fragile. Looking at reporting specifically, there are several needs between the system, like the image display system, the PACS, needs to integrate with the reporting tools for authoring purpose. So That is done usually by the image-centric specialists like the radiologists. Once the report is done and finalized, it needs to be stored and exchanged to the report repository so that later on, excuse me, other system, whether it's the EMR or the PACS, they can view those reports by the referring physicians or other radiologists as a prior. There are barriers between each boundary between these systems today. And I'm going to introduce two new profiles that try to address some of these concerns. The first one is IRA, or Integrated Reporting Applications. It addresses the communication between your PACS and the reporting tools. It used FileCast as a foundation technology. It supports context switching, which means when you open a study in your PACS, the reporting tool will automatically switch the context to that study so that it knows it's now reporting to that study. When you switch to another study, it will do the same thing. And beyond just context switching, it also supports content sharing. What I mean by that is like a system, when you create a markup or when you create some new observations by AI applications, that content that it created can be shared immediately between those systems that are part of the same reporting session so that they can react to those results more immediately, um, while like the results will be captured in a more persistent storage like the DICOM SR in the background. It also supports suspend and resume because quite often we know that radiologists get interrupted for different tasks. So having able to support suspend resume is important so that when they get interrupted, they can come back to the same state in the system rather than have to go through the same work over again. And then regarding report exchange, another profile that I'm going to talk about more is the interactive multimedia report. It addresses the report exchange by capturing a content-rich report using FHIR diagnostic report. It supports capturing the rich content with hyperlinks that people can interact and load image reference in the report or measurements that people dictated in the report, and you can click on the hyperlink with the measurement and show the images that like where the measurement derived from. The diagnostic report, excuse me, as a baseline, it support HTML as a report, but for backward compatibility and other system integration, it also support PDF and text reference. The rich content will focus on image references as well as measurements, but other multimedia contents can be enhanced in the future. Last but not least, once the reports are created, you want to be able to view that. So in the same profile, IMR, it defines several mechanisms. First, you have to find where the reports are. So it introduced a query retrieve mechanism using FHIR because the report is stored as a FHIR diagnostic report. That actually is a new capabilities people don't talk about a lot because reports today are pushed between systems using HL7 or RU. There's actually no query mechanism. I'm out introduce that new capabilities that can help a lot of like existing system integration. Then as a viewer, you can render the FHIR diagnostic report with all the hyperlinks and multimedia contents so that the user can click on those links and see richer content. Or you can use the render PDF and show the user with all the hyperlinks already built into the PDF. It also defines display requirements when you interactively viewing the report. With that overview, let me now dive deeper into the two profiles. With IRA, as I mentioned earlier, it uses FileCast. It's used a newer version of FileCast. And in general, FileCast is a public publication and subscription model. So you send a message to a hub. The hub will manage the subscription, which other system are interested in certain messages. Then it will distribute the notification to say there's a new message that you're interested. Then the subscriber application, they can react to the content. The content in the message is using FHIR R5 resources. Those are transient message in the sense that they only exist within the Firecast network. They don't necessarily exist in the FHIR server. If the system decided that that FHIR resource should be persisted, you are welcome to actually persist that in the FHIR server. But the message inside the Firecast messaging system is transient. As I mentioned, it supports context switching and content sharing, and that is done by 4 specific messages defined in the profile that is based on Firecast. The open and close start and close the context. So when you start with a new study, then you open a new context. When you're done with that study, you can close the context. Content sharing is using 2 other messages, update and select. Update, basically, you contribute new contents. Like, for example, there's a imaging selection that you incorporate some markups and annotations, or new observations that coming from AI applications. Those new contents can be using the update message to share with all the other applications in the session. Select is bring certain content already in Hub to bring it up in focus. I'll talk about more details about that specific use case. It's a very interesting use case. How can you select? I mentioned how the profile also supports suspend and resume. It has specific requirements on the system so that when you resume, you're required to bring up the state of the system back to the same state as when it is suspended. The mechanisms, it uses 2 network protocol, HTTPS for all the requests, and all the events and the pops up mechanism between system is using WebSocket. So you have a quick response without waiting for a polling mechanism. The whole profile complement AIR and IML very well, and I'll show you examples how that can be done in a second. IR target 5 main system. There's in the center of that, there's a hub that manages all the messages and subscription. So all the other system can connect to a reporting session and receive events. And then the 2 main actors is the image display. So usually there's a text that can the user is dictating, looking at the images and reporting. And with the viewing capabilities, it can send all the viewing information through the hub to other system. And then the reporting creator is the your authoring tool that listen to those events and make updates to the report in real time. As I mentioned earlier, quite often many integration today, there may be a more sophisticated work list for optimizing workflow, as well as evidence creator like the AI applications that can also participate in this integration. The second profile I mentioned earlier is the IMR. It mainly focuses on 3 different parts. The first part is how to encode the multimedia contents. So there's the narrative text that's similar to the reporting text in a radiology report today. And the new thing introduced in IMR is you can incorporate image reference or other measurements and regions with the specific tag in the narrative text, so that when the viewer render that report, it can show the multimedia contents. And then the second introduction in IMR is the embedded hyperlinks. It defines how those links should be defined and embedded within the narrative text so that the viewer, they can have interaction with the report. And last but not least is the interactivity. When you interact with the report, there's specific requirements on what capabilities you need to show the images, like how you can actually show the key images in a series and link to the original study, for example. And depends on the different references in the being captured. There are also specific requirements about like scrolling of images, like MPR, MIP, that kind of like specific requirements. So with that overview in mind, sorry, IMR focus on three actors. The report creator that can create those like content-rich multimedia report. There's an image manager that can store those reports, and then a report reader or a sibling, which is a slightly easier implementation, is the render report reader that can look at the PDF, the report reader as to render the whole report on its own. It is more feature rich, more capabilities, but it's also more complex. So those three actors work together to give you the new interactive capabilities of this multimedia contents in the report. With this said, now you have an overview and some more details on the two profiles. I'll walk you through some scenarios, how all these profiles can work together to give you a new experience on how to integrate all these informations. And for the interest of time, I focus on some of the more interesting part of the integration. So how to set up the sessions, I skip that part of the integration. So putting all this together, let's say there's a new study open in the worklist by a radiologist. So when that is done, the worklist client send an open message to open a new context. In this case, study set. That message goes to the hub, and depends on the subscription, it will distribute that content to the subscriber in the reporting session. So in this case, all the image display, the evidence creator, as well as the report creator receive that message. Independently react to that message. Some applications may have nothing to do with an open session, like the AI applications. The image display may open the study and ready for reading. The report creator will prepare the study and ready for reporting. Later on, the radiologist at the workstation create some markup. With that new information, the PACS can create an update event and capture the markup using an imaging selection file resource and send it to the hub. The hub again will distribute that event to all the clients. And then the AI applications may look at that information and say, oh, there's a markup. Let me see if there's any other AI inference I can execute to give you more information about that specific region of interest. And once that AI application finds something, it can turn around and send another update message to the hub with an observation that capture what the AI application has found. That information will be distributed to the different applications. The image display can show the additional AI results that come from the applications. The report creator can also start tracking those observations in the background. Then the user look at all the results that have identified so far and pick one of the more important one and want to incorporate that into the report. So the users select one of the findings, and with that action, selecting the finding, the PACS can set a select event to the hub, and that select event reference that specific findings or observation. Again, the notification sent to all the system. The report creator now put that specific measurements or findings in focus. What that means is now that observation is active within the report creator, waiting for some actions to apply to it. And what the action may be, like the user may use the mic, then say insert measurement. And that command, that voice command on the reporting system will apply to the active content, which is the measurement. And the report creator knows that, okay, that is the active observation. It will add that measurements, maybe including the image number, the series number, as well as all the specific measurements in the report directly. So that is one example how to use the select event. And with that real-time integration, now the reporting system is much easier to actually inject all those rich contents in the report directly, because in the past that is complicated, since like the two systems, they don't have like a real-time data sync. And now with that rich information, as a viewer, a renderer, can read the report and render with hyperlinks and let the user use the report much easier with much richer content. And with that said, and that is an overview of how the workflow with all the profiles put together that can give the user much richer experience. With that said, now back to David and Michael.
Thank you, Kinson. I have the last agenda item, which is to tell you a little bit something about the IHE North American Plugathon that's coming in for the Connectathon week in Toronto. Plugathon is a relatively new activity. It was introduced by IHE Europe. It was very successful this past June in Trieste, where they combine education and innovation. So they would start a session off or a stream with a lecture, and then having some thought leaders and technical leads create a very collegial environment to brainstorm. Our thought for the Plugathon is there's always activity going on in terms of working up ballots for new profiles. This is an environment or a setting that is perfect for that. If you're working on some challenging gaps, bring them, have a discussion, and it could turn into a technical profile. I know there's a few that are always floating out there in radiology. There's no shortage of submissions for new profiles. And this is one way to do a workup on it and get it to a point where it's ready for submission. Other areas are, if you're just wondering, there's a challenging problem. Don't forget, we're anticipating that there's close to 270 to 200, about 270 software developers and engineers coming to Toronto. So there's a lot of brain power in the ballrooms, and we hope to track some of them down into the Plugathon to play, and to again, we're trying to create something that is a little bit more formalized than a hackathon. And again, it's a setting for innovation and progressing. Mike, I hope that suffices. If there's anything else you want to add. Yes, Kevin. Kevin has volunteered to be a co-lead with me in at least 1 to 2 of these tracks in the Plugathon. Go ahead, Kevin.
Sure, and just to put a little color on it, that one thing you could imagine, you just heard Kinson describing one pattern of interactions between, say, display applications and report applications, and how they could coordinate back and forth using one of the existing profiles. You could imagine if you've got some ideas about how you might want to take advantage of that, and you'd like to play through it with some of your partners, the Plugathon's a wonderful opportunity for that. The one in Trieste, there's a lot of focus on how do you capture assessments of AI results. The radiologist says, wait, that segmentation was garbage. This detection of a pneumothorax was a good catch. The pluses and the minuses, how do we capture that information? That was the topic of one of the sessions in the Trieste Plugathon, which led to a profile this go around. So those kinds of, if you've got practical problems and you'd like to spend some time with your partners, the Plugathon's a wonderful place to start, doing the skunk works activities.
Thanks, Kevin. I'm going to turn it back to you, Michael.
Yeah, thanks. Well, first of all, I'd like to, on all our behalf, thank our panelists, David and Kevin and Kinson, on a really well thought out and very, very interesting set of presentations around AI and imaging. Just a reminder, I think we'll have time to do one question. So whoever gets the next question and gets to ask the question on the webinar. Just wanted to remind you that this recording of this webinar will be posted on the YouTube site and the IHE International's channel. And of course, feel free to circulate it to your colleagues. There's also some QR codes that will lead you directly to the profile descriptions that have been presented in this webinar. And there's lots of material online on the IHE Connectathon Week 2025 in Toronto. Emily has posted a link in the chat if you want to learn more about that, or you can go to IHE USA's website and you'll find it there as well. Lots to go on. We hope we've motivated you to think about coming to be one of the people in that photo, side by side with your colleagues and your competitors, to test and prove your abilities to interoperate with one another. I don't see any questions. It's just about the top of the hour, so why don't we close the webinar now? Again, thank you all for attending. We hope you got some value out of this, and hope to see you in Toronto in February. Bye, everybody.
Bye, all.
Very good.
All right. Thanks. We're right on time. That's good.
Nice and tidy.
Awesome job.
Thanks.
Thank you both for your time.
Thanks, Emily.
Bye.
Bye.